So in the last lesson, we were looking at how to solve linear ODEs, and we'll need to use that for this lesson. The only thing that's really different about this lesson, you'll notice if you look at the questions, is that all of these questions are word-based. So the idea for this lesson is we change our word-based problems into linear ODE problems to solve. So just a little bit of vocabulary. Proportional means this. So for example, if I say proportional is this symbol, and if I say A is proportional to B, that does not mean A equals B. I mean it could, but not necessarily. What it means that if I double A, then I double B, or triple, or whatever. So an example might be, for example, mass is proportional to volume of a gas, an object, a person, whatever. So you have this idea that if you make the volume maybe go from 10 meters cubed to 20 meters cubed, if the mass was 5 kilograms, then you expect this mass now to be 10 kilograms. So the question is, how can we change a proportional into an equal sign? So if you want to go from proportional to equals, which is more useful, you just have to put in a constant. So in this example here, where A is mass and B is volume, maybe somebody can see what would the K need to be here. Yeah, I think it would need to be a half actually, because you would need to have, for example, mass equals a half the volume. For example, if the volume is 10 times a half is the 5. And if the volume is 20 times the half is 10. So here the K is a half. So this K is called the proportionality constant. So that's the first piece of vocabulary. Okay, second piece. So first word, proportional. Second word, phrase, rate of change, or sometimes written as rate of change with respect to time. And all this is the time derivative. So for example, rate of change of mass, that would be dm dt. Or for example, rate of change of volume, dv dt. So largely it's these two terms, proportional and rate of change, which you'll need. Write this down. Okay, so I think I have an example of this. you know nuclei from chemistry. Everybody does chemistry. Okay, so here's my nucleus made up of its nucleon, protons and neutrons inside it. And what's happening here is the protons and neutrons are leaving. So we shall use n to represent how many protons and neutrons we have. And there's a law here that says the rate of change of n, the number of protons and neutrons remaining, is proportional to n. So this is a very typical type of problem which you could get in the exam and for this topic. So we have a law that says the rate of change of n, the number of protons and neutrons remaining, is proportional to n. So in other words, if we have a lot of n, then the rate of change is very big, and when the n is very small, the rate of change is very small. And I'll also tell you that at the beginning we have n0 at the beginning. So what we have to do with these types of problems is we have to write them as an equation. So the rate of change of n, that's dn dt, that's proportional to n. So that means dn dt equals kn. So that means dn over n equals k dt, which I can integrate. So I get log n equals kt plus c, but you know that when t is 0, n equals n0, so if you put that in, you can get the c. Log n0 equals k0 plus c, so then c equals log n0. So if I substitute that back into here, I get log n equals kt plus log n0. Now, if I want to get rid of the log, I can put an e on both sides. So with my e on both sides, I now get e and log cancel, so that's n equals e kt e log n0. And I'm using the first rule of powers here. But log and e cancel again, so you're left with n equals n0 e kt. Now in this example, we'll look at the next one. It is possible to find the k as well, you just would need another point. So we use the first point at the beginning that we have n0. That gave us the n0 and the answer there. And if I want to find out what the k is, I need to be told something else, like how many n's I have after 1 minute or something. Yeah? Yeah, now the plus and the minus, I was going to talk about that. If, back here, you could write a plus or a minus here, it's not important for the k. So for example, I didn't write plus or minus, but I know for this type of problem the k will end up being negative. But if I wrote a minus up at the start, then there'll be a minus here, and so then the k will have to be positive. So the plus or the minus is not really so important. What's more important is the value this takes with whatever you put in front. No, it really doesn't matter. Really doesn't matter. Let me continue it. Let me give you a point, another point on this. So let me say, if I go back here, that maybe after, I'm not doing exactly like the first one, but in the first one I do give you more information, do I? What else do I tell you? Do I tell you what the N0 is?
Yeah.
What is it? 1,000, okay. So in my first example, N0 is 1,000, so I'll just write that in. And then do I give you another point in time? The time for 500?
5,600.
Oh, I think I meant to say 500 then.
It is equal to 500, but the time is 5,600.
Yeah, when the time is 5,600, the n is equal to 500. Okay. So with this information, we can now find the k. So if I put that in, this is exactly like what you did in semester 1 anyways, when we did practical problems for exponential and logs. So this is 500 equals 1,000 e power 5,600 t. Okay. So this is 0.5 equals e power 5600k. 500 over 1,000 is a half. I log both sides and they cancel. So I get log 0.5 equals 5600k. Divide by k. 5600 I mean. And you'll notice soon the k will be negative here. So what value do I get for k? 10 to the minus 4. 1.24, like this. So we have our answer n equals 1,000 e minus 0.000124 t. Is that the answer at the back? If it is the answer at the back, then I definitely should have had 500. And there's 100?
Yeah, the 100 e to the power is correct.
So I'm messing up my zeros then.
So which one of them is the general solution?
This one. But the information in the question, just scratch out the 0 and the 5,000 to make it a 500. And then this is the right answer.
But this is a specific word.
Yep. Oh yeah, the general solution is the one before you find the values of the constants. So for here.
N equals N0.
Yeah. Where's it gone? Here. This is called the general solution. Because it is a general solution. You don't have values for the constants. You know that the solution will look like this, of this form.
What's the answer for the first part? Express this and ODE.
Oh yeah, and then the first part is actually just write this as an equation, really. So you could do it like this or like this. So is part 1, find the equation, yeah? So that's part 1, and then what's part 2?
General solution.
The general solution, then that's here, that's part 2. And then finally, the specific or particular solution?
Yeah, but then we need to find t.
No, we just, for that I just mean find the constants. Okay, so we'll have a look at another one. I'll try and think the chemistry one. But before I do, let me just show you quickly your assignment, because your assignment is based off of this.
How much time do you have?
Oh, what was the date you had on the schedule Lorraine sent you? Whatever that date is. Project. I'll give this to you in the tutorial.
Can you show us the markings?
No, sorry, I'll pass on that case. So this one is about Newton's law of cooling or heating. So in this, I don't tell you what the law is. So the first thing you're going to have to do is find this law. So in this question, what you have is you have a cylinder of this radius and this height, and you put this in a heat bath. Do you know what a heat bath is? Yeah, do you use it in biology, don't you? Heat bath is just something, it is actually a bath of water at an exact temperature, and whatever you put into it will reach that temperature. So in other words, it's a way of putting something to an exact temperature. And there is 0.1203 moles of gas in the cylinder. Initially, the cylinder is at a lower temperature than the heat bath. So when you put it into the heat bath, it will warm up. After some time, it will heat up according to Newton's law of cooling or heating. So you're going to have to find this law. This will cause the pressure in the component to rise until it reaches critical pressure and then explodes. And the explosion happens at 90 kilopascals. But you don't actually do this. What you do is you heat it up a little bit, and your goal is to work out the time it will take to reach 90 kilopascals. So in fact, on Moodle, I give you some data, but the data is not for all the temperature and pressure, it's just for enough at the start. A bit like in my example I just did here. How many points of data did you need to get this formula? You only needed 2, one at the beginning and then one 5,600 seconds later. But now that you have this formula, you can work out the n for any time, or you can work out the time for any n. That's kind of the idea I'm getting at here. So your goal is get the data from Moodle, plot the data, state the law in words, state it as an ODE and solve it, find the values of the constant, use the ideal gas law to find a formula for pressure, because remember, this is only going to be for temperature, and you don't care about temperature, you care about pressure. And then finally, find the time required for the pressure to reach critical. Okay, let's have a look at another example then.
How many words should you
What did I say? I think about, it's a bit more than the last one. Is it about the same? 750, that's what it says the last one, 750 to 850. Anyways, it's one of those things where the more you write, the more marks you will get. So I know some teachers have maybe limits, do they, on their word count or not? You were never told never to go over a certain number, no?
Sometimes Larry says to cut it out if you have too much.
Okay. The more the better. Okay. Alright, let's have a look at another example. So let's look at one that you would have done in chemistry. Have you done reaction rate in chemistry?
Yes.
Was it our 9 o'clock class that you did it?
We did it like for a couple of weeks.
Couple of days?
Yeah.
Were they all 9 o'clock classes?
She gave us the formula, we didn't really do that.
But no, of course not. What I really want to know is, do you understand the term reaction rate? Maybe you haven't done problems with it, that's fine. So what is reaction rate? If you understand it, what does it mean? Or what does it tell you? Not quite that, no. Not that either. Anyone else? Say that again, I think you might have it, yeah?
Outside the product forms or reactants to be.
Yes, that's it, yeah. It's like a speed. Reaction rate is how quickly the product is formed, isn't it? Yeah. So the reaction rate is the rate of change of in my example I'll say reactant, okay? Oh, well actually I should be a bit more particular. It's not the rate of change of reactant, but rather it's the rate of change of concentration of reactant. Rate of change of concentration of reactant. Can you think of any simple reactions in chemistry? What's the simplest one? So HCl, and NO, Na, sodium and hydrochloric acid. And then what do you get? Hydrogen, is it, or what do you get?
Water and salt.
Water and salt, okay. So what do we have? We have HCl plus Na, OH. And then this becomes water and salt then. Great, okay. So what I'm going to look at, for example, is just one of the reactants. So in this case, HCl. You wouldn't have any numbers as an example, so we'll have to make up something. But the idea is we're looking at one of the reactants, okay? And what tends to happen to reactants? Do they increase in concentration or decrease in concentration? Usually decrease. Maybe always decrease. But usually decrease anyways, okay? So we need a way of working out, like in the last example, a formula for the concentration of a reactant. So we know at the beginning we have so much concentration, like maybe, I don't know, 1 mole per liter, and then it'll decrease down. Okay? So, just before that, I just want somebody or anybody to tell me if they've heard this in chemistry: first order rate law.
Yes.
Yeah, so before you do, what was your question, Tanish?
No, I was just suggesting that.
Oh, okay. Well, it's not really, I'm just going to pick some substance called X. It's not important for me right now. And you know this one, first order rate law. Do you? Right, so somebody tell me what it is if they know it. Huh?
The H equals to the constant times the 1 reactant.
He did this in chemistry. Yep. So you have, and that's right, I think a bit more general would be, so the first order rate law is the reaction rate. Reaction rate is proportional to the concentration of the reactant. So reaction rate is proportional to the concentration of the reactant. So when the concentration is high, the rate is big, and when the concentration is low, the rate is small. So in other words, when the concentration is high, the rate of reaction, the rate at which the reactant is chemically interacting is bigger the higher the concentration. But I mean, that's not surprising. If you have more HCl, then you expect more stuff to happen than when you have little or no HCl. So let's try and put this into a formula and solve it. So I said I'll just write OR for reaction rate is proportional to the concentration of the reactant. And I'll just call my reactant A. Whatever it is, HCl, whatever. So reaction rate is, remember, the rate of change of concentration. So here we have the rate of change of concentration. So again, we can get rid of our proportional constant. Getting rid of our proportional constant. So we have this. So this is our ordinary differential equation which we would like to solve. So let's go ahead and solve it. I have dA over A equals K dt. I integrate both as normal. So on the left I get log A equals kt plus c. So if I put e on both sides now, I get e log A concentration. I'm sorry, I should have checked. Do you use the same symbol for concentration with the square brackets or not? You do? Okay. That equals e kt plus c. So you get log A equals ec ekt. Oh, sorry, that log is gone. E and log cancel. You don't have to, but it's normal here to recognize that C is a constant and E is a constant. So together they're still a constant. So we could actually write this as some constant. I don't want to use A because I'm using that already, so I'll use B. Some constant E power kt. Now you don't have to do that, but it's normal to do that here. And this is called the general solution. In fact, the k will be a negative number here again. So we need some information to find the b. So let's say, for example, when T is 0, the concentration of A, what would we say, 2 moles per liter? So 2 moles per liter, we'll say. So if I put that in, I get 2 equals BE0. So you can see that B equals 2. And then let's say we have another point of information. When T equals, let's say it's, I don't know, how quickly would this, if we're doing HCl, how quickly until it kind of dies down? You haven't seen this one?
5.
No? Is it about 5?
If 2 would be less than 5.
2 is less than 5, yes. Alright, let's just go with, let's say after 4 seconds the concentration is 1 mole per liter. Okay, so if I put this in now, I get 1 equals 2 e power 4t. So 0.5 equals 4k, I did it again, sorry, 4k, 2e4k, sorry, I brought the 2 down, e4k. So if I put a log on both sides, log and log, I get log 0.5 equals 4k. So then k would equal log 0.5 over 4, which is what that is, minus 0.28 or something?
Minus 0.17.
Oh, sorry, minus 0.17. Give us one more. 3. Okay. So now you have your answer. Concentration equals 2e minus 0.173 t. So So what you've done now is you've found a formula to work out the concentration level at any time. So you give me any time, and then I can tell you how much of the reactant is left in the solution.
So we need to remember the equation of the rate of reaction.
No, in the exam what will happen is they'll state something in words. So they could state the law I had here, reaction rate is proportional to the concentration of reactant. What's that? Oh, it's going to be like in the book, yeah. Yeah. Let's see. Okay. What I'd like you to do, and then I'll do it on the board. Can I scroll down? Yeah. So what I just did there was called the first order rate law. In fact, there's a second order rate law. Does anyone know this one? You did it in chemistry? So the second order rate law, what does it say? That reaction rate is proportional something, and done. Proportional to, that's the first order rate law. Two reactants? Yeah, so let's imagine I only have one reactant, for example. No. So in my example of only one reactant, because if we had 2 or 3 reactants, the problem gets a little bit too complicated for us. So if we had only one reactant, reaction rate is proportional to the square, which is like what you just said, you multiply the two together. So if there's only one reactant, then it's a square. Reaction rate is proportional to the square of the concentration. Of the reactant. So what I'd like you to do for me now is just give me the general solution. Don't worry about finding constants. So I'll just tell you when T equals 0, you can say that the concentration level equals A0. And you don't have to worry about finding K or anything. So give me the general solution. have it, Jack?
Okay.
Yes. What type of answer did you get? Did you get an E or a log in the answer?
No.
No, you shouldn't in this case. So the fact that there's a square actually changes it a bit. So if I look here, I'm saying that the reaction rate is proportional to the concentration squared. So that means the rate of change of concentration equals K times concentration squared. So if I take that to the left, it becomes a -2 because it's in the denominator. I integrate both sides. I get concentration -1 over -1 equals Kt plus C. So here I get 1 over concentration equals minus Kt minus C. So I get concentration equals -1 over Kt plus C. I can just leave the minus on the outside. No need to multiply it in. Now, you know when T is 0, the concentration is A0. So that means here we have A0 equals -1 over C. So therefore, C equals -1 over A0. So I can put that back in now. And I get concentration equals -1 over Kt minus 1 over that. Now I'll clean this up a little bit. What I'll do is I'll multiply the top by A0 and the bottom by A0. So I get concentration equals minus the concentration at the start all over K concentration T minus 1. And then to finish, I'll multiply the top and bottom by -1. So I get concentration equals concentration at the start over 1 minus K times concentration times T. But you realize, well, this is a constant and this is a constant. So if you want, you can just replace them by one constant. This is fine to do. So you don't have to. You can actually stop here, and that's perfectly fine. And I would think, in fact, most chemistry books would stop here, because this little proof is in chemistry books. So most of them would stop here. But you could write it like this if you wanted to. Some other constant times T. Yes? Yeah, I can zoom out twice. Can you still see it? Hey, what did I say 30 seconds ago, people? Kt plus C? How far back are you looking? Oh, here? No, because in this case we can find the C. Well, we can at least replace it by another constant, because I told you this. This is to let us find the C. Now, if I didn't tell you that, Joshua, you're right. You could stop here if I didn't tell you that. But because I gave you that, you could use that to find the C. And if I give you another piece of information, you can use that to find the B. But look, this is still pretty general, because the information I told you is not specific. It's true for every question. I said at the beginning the concentration level is A0. Well, that's true for everything. At the beginning the concentration is some value. So I'm not even giving you anything specific there. I just said at the beginning it is a value, which I'm going to call A0. But I didn't even tell you what A0 was. So it's still, this answer would still be considered a general answer, because there's no real values in for the constants. Do you think this concentration level will decrease faster or slower than the first order? So second order faster or slower? What do you think?
Slower.
Yeah, I think it's slower because if you look at the first one, what type of solution did we get? Exponential, wasn't it? An exponential decreases very quickly. Whereas this one here, here it starts off, they both start off at A0. I don't think this one's decreasing as fast. So in fact the second order rate law, when it applies, would mean that the reactant does not decrease as quickly in its concentration as a first order problem. Okay. Now this lesson is very important. Joshua, what's wrong? Don't laugh at Charles, you're hurting his feelings, okay? Please. Thank you, Joshua. Compose yourself. Right, this lesson is very important for your assignment. Okay? And it's really a pity that half the class are missing for this important lesson. You plan interviews going on now?
Yeah.
Where's that happening?
In the conference center.
Want to crash it later? Yeah.
You're in student.
In my suit, yeah. Hello, I want to be a doctor.
Yeah, that's a cool.
Oh yes, I need to go back. Yeah, no, I remember these interviews from each year. Everybody wears suits. So who will we see in a suit? Good. Yeah. Yeah, Lou?
Yesterday she was trying to pick a open account for the couple of hours. It doesn't suit me, I don't know what to do.
Nice. In the conference center over there?
Where the canteen is, like
Just above it, yes. Yeah, you'll see them coming out sweating.
And they said that they will finish in a couple of hours.
Yeah.
Yeah.
Okay. Right, now, like I said, sorry, do you have this, Grace? Not yet. How many questions? Okay, we actually wait number 2, actually.
Stephen,
Yes.
the question, where does it know it from section A and B?
I have seen it in both.
Is that to derive the equation of the particle?
Yes, I remember, but I think I made that one of my questions. So I've seen it in both, but it is much more common in section B than A.
As a full question, or
This would be half a question. I'm trying to think what the second half would be. The second half would be another calculus question. So the second half could actually be usually something like Newton-Raphson or fixed point. So this usually goes with Newton-Raphson or fixed point. Now, not always. Sometimes I think I've seen it go with a further trigonometry integration problem. Yeah. But mostly this one goes with Newton-Raphson or fixed point.
It's very common to exam.
Yes, it's common, yeah. Yeah, I mean in most exams. Yeah. So look, I'll give you the page later today in the tutorial so you can start your assignment. And just have a look at the calendar Lorraine emailed you. The date, what's that?
Submission is 27th April.
27th of April. Yeah, that's what I have in mind. Yeah, but I said I'm doing this chapter early so I can give you more time to do it.
yeah, that's great. It was like, oh my god, that's the month. It was like, thank you.
Oh yes, okay, sure. 27th of April. In fact, it's over a month, because it's the 23rd. So it's a month and a week,
Yeah,
alright?
we'll have 1 week break, so.
Oh, so it's a month then. Yeah. So just remember, as you're working on it, if you have questions or you want me to check what you've done so far, you can show me, I can give you feedback on it. The date, oh yeah, for this assignment, the data is on Moodle. So if you go to Moodle, there's a link that says data for assignment or something like this, okay? Yes, if you enter your student number, everybody will get different data.
It generates different data.
That's right, that's how I roll. So everybody will have a different answer. Yeah. Huh?
I mean, that thing is
I know, but I mean, it just would, it creates a smaller barrier for copying there. If I kept it the same, then I'd expect a lot more copying. But at least with different numbers, then you have to recalculate things. So it forces the people who plagiarize to do some work, which they don't like doing. That's why they plagiarize.
That's like smart thing.
Yeah. Okay, so we'll just leave it there, and in the tutorial later, what's wrong? In the tutorial later, I'll give you the page with the instructions on it, okay? Alright.